class. So today we're going to talk about the Calvin cycle, and this is a review for the test. So I'm sure all of you already know this, but we'll go over it one more time. Okay, so we start with CO2, and then it moves on to carbon fixation.
What I ate for breakfast again? Oh yeah, I had a muffin. That was really good. Blueberries. Focus. Is it bad that I already lost her after carbon fix? Whatever, I don't even know what she's saying. I can't understand anything she's trying to explain. How am I supposed to be ready for her test when I can't even understand what's going on, let alone understand what she's saying? I swear she's speaking gibberish. Maybe she'll give me partial credit for drawing a picture of a guy named Kelvin and saying he goes through some sort of cycle? Ugh, no, I need to find some sort of way to study.
Okay, so is everybody clear with this? This should be the easiest part, and hopefully everybody knows it for the test.
Ooh, look, a new message. Did she just say easiest part? Focus, Valeria. Wait, what? Ugh, wait, hang on a second. This is just not in English anymore. Is anyone else seeing this, or am I the only one? Should I be trying to take notes on this? Okay, let me see. A Q-looking thing equals whatever that is, and then emphasis on what? Okay, Blair, focus on 3. 1, 2, 3. Ugh, okay, that was really hard to give up.
Okay, now does everyone understand? Okay, perfect.
Maybe a YouTube video will help clear things up for me. Let's see. Photosynthesis. Alright, let's see what we got. Well, this one looks like it'd be good. Let's check it out. A photon hits a pigment and its energy is passed among pigment molecules until it excites P680. An excited electron from P680 is transferred to the primary electron acceptor. We now call it P680+. H2O is split by enzymes, and electrons are transferred from the hydrogen atoms to P680+, reducing it once again to P680. O2 is released as a byproduct of this reaction. Each electron then falls down an electron transport chain where it goes from PS2 to PS1. The diffusion of H+ across the membrane drives ATP synthesis. After the electron has been carried through the electron transport chain, photosystem 1 is now ready. In PS1, like PS2, transfer light energy excites P700, causing it to lose an electron to the primary electron acceptor. Photoexcited electrons are passed in a series of redox reactions from the primary electron acceptor down a second electron transport chain. 2 electrons are required for the reduction of NADP+ to NADPH. In certain cases, electrons can take an alternative path called cyclic electron flow, which uses photosystem 1 but not photosystem 2. In the cyclic electron flow, electrons cycle back from ferredoxin to the cytochrome complex, where it then cycles back to photosystem 1. There is no production of NADPH and no release of oxygen, but the cyclic flow does, however, generate ATP. ATP synthase. Chloroplasts and mitochondria generate ATP by a mechanism called chemiosmosis. Built into the plasma membrane is an ATP synthase complex that couples the diffusion of hydrogen ions down their gradient to the phosphorylation of ADP. The Calvin cycle is anabolic, building carbohydrates from smaller molecules and consuming energy. During the first phase, carbon fixation, the Calvin cycle incorporates each CO2 molecule one at a time by attaching it to a 5-carbon sugar named RUBP. The end product is a 6-carbon intermediate so unstable it immediately splits in half, forming 2 molecules of 3-phosphoglycerate. During phase 2 of reduction, each molecule of 3-phosphoglycerate receives an additional phosphate group from ATP, becoming 1,3-biphosphoglycerate. Next, a pair of electrons donated from NADPH reduces 1,3-biphosphoglycerate, which also loses a phosphate group, becoming G3P. Notice that for every 3 molecules of CO2 that enter the cycle, there are 6 molecules of G3P formed, but only 1 molecule can be counted as a net gain of carbohydrate. Phase 3. In a complex series of reactions, the carbon skeletons of 5 molecules of G3P are rearranged by the last steps of the Calvin cycle into 3 molecules of RUBP. To accomplish this, the cycle spends 3 more molecules of ATP. The RUBP is now prepared to receive CO2 again, and the cycle continues.
Swing